Hello everyone, or dzień dobry, which is some of the Polish I know. I know very little, sorry. I'm Marit van Dijk. I'm a developer advocate at JetBrains and a Java champion, and I've worked in IT for 20 plus years. And today I want to talk about reading code. Because as developers, we spend more time reading code than we do writing code. We read code when we're adding new features or fixing bugs, or when we have to understand a new system, when we're doing code reviews, when we're learning new technologies and reading books or watching videos, or I don't know, maybe getting Gen AI to write the code for us. Hopefully we still try to understand that before we commit it, right? In fact, developers on average spend as much as 58% of their time comprehending existing source code. That's a quote from a book by Feline Hermans called The Programmer's Brain, and the subtitle is What Every Programmer Should Know About Cognition. For those of you who don't know Feline, she's a literal professor of computer science education at Vrije Universiteit in Amsterdam. And she does a lot of interesting work. Her research domain is literally teaching programming and how to teach programming. And I highly recommend this book. I don't get a commission. But it's very interesting. So we spend more time reading code than we do writing code, but we don't practice reading code much. We practice writing code, but we don't practice reading code. And even if we do talk about readability, it's often about how to write readable code, which is still not practicing how to read that code. So Feline is also a conference speaker, and she did a talk at Strange Loop in 2019 called How to Teach Programming and Other Things. And in this talk, she talks about research from 1992, where they split a group or a class of computer science students into 3 groups. And they, the first group would write code and read code. The second group would write code and read code, but that code had explanations. So, for example, it would say like why a particular implementation was chosen or what design decisions were made in that code. And the third group would only read that code with that explanation. And what they found was that actually group 2 and 3, who read code with explanations, were better able to reproduce the programming concepts from the class than the first group who wrote a lot of code, which is interesting because we all learn programming by writing lots of code, right? So after that talk, someone came up to Feline and said, what if we do practice reading code explicitly? And that's how Code Reading Club was born. They started Code Reading Club as an experiment to see whether they could deliberately practice reading code. And I read or heard about that somewhere because I follow Feline on socials, and I thought, oh, that sounds really interesting. I want to try that. And then I got really lucky because a friend of mine was actually starting a code reading club, and she reached out whether I wanted to join that club. I'm like, yes, I do. So that was a few years ago. We've been having a monthly code reading club since then, and it kind of petered out, but I do want to share my experiences from that. So what we do in Code Reading Club is we take a printed sample of code and then apply structured exercises to it. So we actually annotate the code on a piece of paper. Coincidentally, you get to play with colored markers, which as adults we don't get to do so much anymore. So added bonus. And I'll talk you through some of the exercises that we do. So the first exercise we usually start with is called First Glance. That's literally what it is. You take 1 minute to look at the piece of code and write down the first thing that you notice about the code and why. And that's already interesting because some people will notice, oh, I see a familiar concept that gives me a hint of what this code is about. Or people might notice, I see some syntax here that I have absolutely no idea about, and I want to know what that means so that I can make sense of this code. So it's really interesting to me that different people notice different things. Next, we might look at identifying components and relationships. As you might have seen in the previous picture, you know, you circle things and then draw lines between them so you can see what is being used in the code and where, and gives you a bit of an idea of the control flow in the code as well. Another exercise we do is we identify the 5 most important lines in this piece of code, which again is very interesting, especially if you don't upfront agree on what most important means. And in our code reading club, we have people from different countries who use different programming languages, who have different roles from developer advocate to developer to tester to quality coach. And if we don't agree upfront what most important means, we will select completely different lines. Some might select the lines, these lines determine the control flow through the code. I mentioned we have some testers in there. They selected these lines is where stuff happens that I definitely need lots of test cases for. So again, different perspectives make you notice different things in the code, which I found very interesting. We also identify the concepts in the code to see whether we can make sense of it. And what's interesting there is there will usually be unfamiliar things in the code or concepts that are unfamiliar to some of the people in the group, but there will always be someone in the group who is able to explain it, and it will always be a different person. So it's really interesting to see that everybody brings something to the group and we can all learn from each other. And finally, after we do all of these exercises, we will take a few minutes to create a summary of what we think the code is about or what the code does. And even though we didn't really look at the meaning of the code in most of the exercises, we'll usually be able to approximate what the code is about. So I really enjoyed doing these code reading clubs, and because I learned not just about reading code and getting better at it or feeling at least more confident in that skill, but I really enjoyed learning about other people's perspectives. And even if you think that the code is clear, other people might notice completely different things and it might not be clear to them. But also in discussing the code, you make your own assumptions more explicit. Sometimes someone in the group would be really focused on, I need to know what this means, or this is very important to me, even though that would be a piece of code that I personally would have skipped, like, oh, that's not relevant for me to understand what this code is about. And then having to make that explicit, explaining to other people your thought process, it was also very interesting to me to be aware of my own thought process. I wrote a blog post about it if you want to read about it. I will share a link to the slides and materials all the way at the end, but do feel free to take pictures and post on socials. So what I like most about Code Reading Club is that we read the code really to understand and not to judge the code. Because who's ever looked at a piece of code and went, that's crap, I would write that completely differently. Okay, so the rest of you are afraid to raise your hands? I promise I won't bite. Some of you at least. Okay, so counter question, who sets out to write bad code? Okay, some people are honest, some people are developer advocates, so I have to deliberately write bad code so that I can then show you how to fix it. But anyway, most people, no hands were raised, or very few hands were raised, most people don't set out to write bad code. And often it's like stuff happens that means that now the code is maybe not how you want it. So reasons why code is confusing. I mentioned the book by Felina. She talks about reasons why code might be confusing when you're trying to understand code. And she mentions a lack of knowledge, a lack of information, or a lack of processing power in the brain. And these, of course, are tied to our cognitive processes. So our long-term memory, the things that we know, our short-term memory, the information that we have available right now, and our working memory, how we process that information. And she also suggests how to deal with those. So a lack of knowledge might be, of course, in the programming domain, if it's an unfamiliar language or syntax, or programming constructs or algorithms that you don't know. Or it can be in the business domain, if you're maybe new to a certain industry or a certain team, you might not be familiar with the domain concepts or the business logic yet. So Felina suggests that for a lack of knowledge, you create a list of the things that you need to research, and you research them, and if there is knowledge in there that you need to know by heart, you might even memorize some of that information. And the reason that she suggests to create a list is to help keep you on track, because who's ever gone to do a little bit of research about someone and then went down a bunch of rabbit holes? Probably not just me. See, some of you as well. So if you have a list, then at least that keeps you on track of the things that you want to research. So a lack of information might be that there are unknown details in the code or unfamiliar names, again, concepts you don't know. Code might be connected in unknown ways, especially if you're not so familiar with a code base, or there can be too many things going on at once, too much data to keep track of, too many variables. So dealing with a lack of information, chunking can help. Who's ever heard that you can keep 7 plus or minus 2 things in your short-term memory? Okay, some of you. So it turns out that it's actually less than that. It's like 2 to 6 things that you can keep in your short-term memory. So if you can chunk information into patterns or concepts, that means that you can fill a slot with one of those instead of the individual components. It means that you can keep more information in your working memory. Finally, we have a lack of processing power in the brain if there are too many processing steps or too many variables to keep track of. And Feline suggests that we deal with that by using memory aids like a dependency graph or a state table. So a dependency graph might look like this. If you have the code and you identify which components are used and where they are used, you get kind of the control flow of that code. This is a piece of Erlang code that I literally took from the Code Reading Club website, so I have no idea where it came from for whoever wants to ask me that in the end. There's usually someone. For a state table, we can keep track of the variables. I'm using a very simple nested loop just to illustrate the point so that we don't get lost in the loop. But I'm sure you have more complicated code where more happens to different variables that you might need to keep track of. So you can use a state table to keep track of those changes. Feline was writing another book called Code Reading in Practice, but unfortunately she put that on hold because she has many, many great ideas and other things that she wanted to work on. But I managed to read the early access version on O'Reilly. And in that book, she talks about dimensions of code reading: structure, domain, concepts, and context. So in terms of structure, we know that code is not read linearly. We don't start at the top and read all the way to the bottom. That's not how the code is run either. In fact, we rather scan the code looking for anchors, looking for the piece that we need for whatever we're working on, and then take it from there. And the more experienced we are, the better we get at scanning for the right piece of code. So in the domain, we have the behavior of the code and the data that it deals with. Obviously, we have the concepts, like we discussed, the programming concepts and the domain concepts. And finally, we have the context. Usually, an application is part of a bigger landscape. It has certain users, and all of that information might be relevant as well to properly understand the application. So when we are reading code, at some point we'll need to, or usually I'm a very top-down kind of person, so I like to start with a big picture of what's going on. You might need to do this if you're joining a new team or a new organization, or you start working on a new code base. Maybe you inherit it from another team, or it's a shared code base that you have to do something, or you want to contribute to open source, whatever. But there will be times when you need to familiarize yourself with a new code base to figure out what does the code do. And again, it can help to have a little bit of context. Before I joined JetBrains, I worked at an online retail platform in the Netherlands. And one of the things that we would do when people joined our team is we would give them like a 1-hour overview of each of our microservices, 1 hour per microservice, to explain, okay, this is what the microservice does. This is the place in the landscape. Here's a little bit of history. Maybe these are the things that we're working on. Are we currently adding new features or doing maintenance mostly? What are the areas of the application that we touch a lot? And that can give you kind of a hint how to familiarize yourself with the application, what might be the parts that you want to look at first. But obviously, we'll want to read the code in our IDE, and a good place to start, obviously, is to start checking out the code. Coincidentally, that's a good check that you have access to the right code, etc., if you're starting in a new company or a new team. And obviously, your IDE can help you. I work for JetBrains. I'm going to use my favorite IDE, which is IntelliJ IDEA. So if we want to familiarize ourselves with a new code base, is this clear enough in the back? Should I zoom more? It's good? Okay, thanks. Dziękuję. So if we want to familiarize ourselves with a new code base, we might start by looking at the program tool window and look at the packages and classes that are there. So here we see that some of the packages contain classes that are maybe more in the programming domain, and some contain classes that are more in the business domain. Who uses Spring, by the way? Quite a lot of people, awesome. Who's familiar with Spring Pet Clinic already? Some people, okay, so I'm using just this project as an example. It's a Spring Pet Clinic, is a demo app by the Spring team. And it's small enough to illustrate some of the things I want to talk about. So we see that we have programming classes, or programming domain and business domain. So we have pets, owners, and vets, or veterinarians, aka pet doctors. So that gives us some idea already of what the application deals with. I like to also always make sure that my project builds before I do anything. We'll use Maven verify, because if we do Maven clean install, Andres Almiral will come and yell at us, even though I know he's in Cologne at the moment, so he can't. But still, let's use Maven verify. So I like to make sure that I can build the project so that I know that I have the right stuff installed, for example, but also to make sure that the project even builds. I like to make sure before I do any changes, because otherwise, if it's broken after my changes, I have to find out whether it was my changes that broke it or it was already broken. In this case, oh, I don't have the right Java version. So that's already interesting. I'm going to quickly ignore that for now. I tempted the demo gods. So, you know, if I had the right Java version, it would build. Because it does actually run, which would be the next thing that I like to do, is I like to make sure that the project runs, which I can then open. Oh, I forgot to say, we use Slido for questions. Scan the code. Or ask me, I'm totally fine taking questions. So if we run the application locally, then we can see what the application does by actually using it. Also, we can then locally test our changes if we make any changes to the code base, which hopefully you test your changes, right? So we can see what this application does. So we can find owners, we can find vets, and they've helpfully created an endpoint that throws an error so that you can see what happens in an application, in a Spring application, when an error is thrown. If you're using JetBrains AI Assistant, you can actually explain that error with AI Assistant, which will open a chat where the error is explained, which can be very useful. In this case, it usually figures out that it's not actually a bug, but an intentionally thrown exception, but it might also tell you how you can then fix that exception. So if you have exceptions in your application, this could be a useful way to figure them out. And if you don't know how to run the project, in this case, you know, it should work with Maven Verify. We can run the application from IntelliJ, but sometimes you need additional information. Also, this is a demo project, so they've very clearly specified how to run the project. But I have worked on teams where the README was literally, this is the repo for this project. And we had, have you seen this in real life? Very helpful, right? So, and we had several different microservices, and each was built in a different way. Some were already on Spring Boot, some were Spring, some were using Jetty. And I'm getting older. I can't remember for each project what is going on. So one of the first things I did was add to the READMEs how to build this particular project, how to run the tests and stuff like that. So if your READMEs are like the previous one, please, for your future self and your future teammates, add information on how to build the project to the README. Finally, we can also use diagrams to help get an idea of what the application does. Sometimes visualization can help you. In this case, it's a fairly small application, so all of the classes almost fit one page. Obviously, if you have a way bigger application, then they might not, but you can search the diagram for, I don't know, pet should be there. Maybe not right now. So then you can zoom in on whichever area of the application you're interested in. Generated or provided diagrams can be great to help give you an idea of what the application is about, but Feline also does recommend drawing your own diagrams, because if you draw your own diagram, you're more actively engaging with the material, and that will actually help you remember it better. An additional benefit is also that maybe you're only interested in part of the application, so you can draw only the part that you're actually interested in for whatever you're working on. Again, I'm old, so I keep a pad by my computer that I usually draw or write on, or to help me process the information. So I'd recommend that. So this is a fairly small application. I think by now we have some idea of what it does, and we might feel comfortable making changes to this application. But what if we have a repository that is way bigger? So as another example, I'm using the Cucumber JVM project, which I happen to know has a lot of modules. I also know that most of the modules have a README to explain what they're about, so I could go and read all of those. But this might be overwhelming, and I might just not know where exactly to start. So there's a very useful feature called dependency matrix. Let me look for matrix, which will show us the, that's fine. Hello? Which doesn't seem to work at the moment. Oh wait, it's doing something. Okay. Anyway, interesting. I don't know if that's because I made a typo somewhere or whatever. So, one more time. There we go. Okay, finding the tools. So, if you open the dependency matrix, obviously this is a matrix. Let me open the project tool window in the back. So here we see the modules sorted alphabetically. And we see that the sorting here is different. That's because the modules that are used by other modules are sorted towards the bottom, and the modules that are using them are on top. And we can then see, according to the legend here, the blue boxes are where there are dependencies between the two. Obviously, it's a matrix, so the rows and columns are the same, but the names in the columns have been omitted, so to make it fit on one screen. If there were any cyclic dependencies, so module A depends on B and B depends on A, they would be marked in red. And if we actually click any of them, we can see the direction. So the green dependency uses the yellow dependency. So in this case, Cucumber Java uses Cucumber Core, which kind of makes sense. And we can click them individually to see for a particular module which other modules that module uses, marked yellow, or which modules it's used by, which are marked green. So that gives you kind of an idea of how the modules are related, which could be useful. So I kind of like the view that gives you. I did a video on it as well that you can find on the IntelliJ IDEA YouTube channel. So, that might be an additional tool to help you make sense of a bigger project. So as we've seen, we get lots of help in the IDE. We can look at the project structure, build and run the project, look at the README. Sometimes I also look at the dependencies to see what libraries and frameworks are used, maybe add them to my list if they're unfamiliar to me. So my list of things to research, and we can use diagrams. Outside of the IDE, we can also look at the components in our application, identify relationships and dependencies between them, identify the concepts that it deals with, and gain some more context to help us better understand the application. Another way that we can look at the application is by looking at a particular slice of the application. So we might find a starting point where to start tracing how things work, and depending on the reason for it, we might look for a generic starting point like a main method or an endpoint to go outside in, or if we're working on a specific task where we have to fix a bug or change some behavior, we might look for specific error messages or exceptions that are thrown, or specific logic or functionality that we need to work with. So obviously, our IDE can help us there as well. So, for example, in the Spring Pet Clinic, we could look for the main method. Let's narrow that down to symbols. So we can look for the main method in our project. Obviously, if it's a Spring project, that's where the Spring magic starts, so it's not necessarily a useful place to start how to figure out how this application works. But in a different type of application, the main method might be a good place. For a Spring application, an endpoint might be more useful. So, for example, we could go to the owner controller, we could look at what endpoints are there, or we could open the endpoints tab and look at endpoints there. We can use that for navigation as well. And also we can, for example, navigate from the controller then down to where something is saved and back up again. This is again a very small application. If in a larger application you might have a service layer in between, and you can go outside in to see how things are connected. We can also use AI Assistant to ask questions about our application, like where, let me type that correctly, where is the SQL to find the owners? And it will explain stuff. Sometimes it will explain more generically how to find that SQL. Sometimes it will actually point you to the right class or the right methods. It's AI, it's non-deterministic, which makes live demoing way more fun and exciting than it should be. So lots of ways to find entry points into your application. You might also be looking for something specific. For example, you see an error being thrown and you want to find out where it's coming from. So you might look for that specific error and then basically trace your way back out. So that's more of a bottom-up approach. So you can see where in the application this is thrown. You can use this little target icon to find basically a "you are here" in the project. That will give you some context, and from there you can figure out how you got there in case, you know, maybe you need to fix an exception or something. There are lots of ways that you can use your IDE for searching and navigating. We can look at recent files, and if we use that same shortcut twice, it will show only the edited files. We can also go for recent locations, so see where you've recently been in the application. I think if we do that twice, it will also only show the edited locations. So both of these can be very useful for navigating. Another way, if you're like trying to find a control flow, for example, you can use bookmarks like so, or if you want to give them a number, oh, apparently I've already used 1 and 2, so I'll use 4 and 5, and then we can use that as well to navigate to those bookmarks, or we can open the bookmark menu and find the bookmarks. So if you want to keep a certain flow or mark certain locations in your repository, you can use bookmarks for that. Coincidentally, also useful if you find other stuff that you want to fix. My previous team never wanted me to do like little bits of cleanup as part of a different story, so I would do them in separate commits, but now I can mark them in the code base so that I can clean them up later. So obviously, if you're reading code in your IDE, then searching and navigating the code is very useful, and familiarizing yourself with how to do so will help you keep your mental cycles for stuff that is more important. Outside of the IDE, it might help you to draw a particular use case related to the task that you're working on, and again, draw your own diagrams related to what you're working on to help you visualize what you're working on. Finally, we might end up with a piece of code that we really need to understand. You've probably been confronted with code that was so confusing that you feel overwhelmed and might not even know where to start. I know that we've had some code like that in our code bases. So this is where the structured exercises might actually help, just because they give you something to do. So if you're confronted with code that is completely overwhelming to you and you don't know where to start, grab any random exercise, and now you're over the hump of overwhelm. You can actually do something. But obviously also your IDE can help you. So if you're reading code in the IDE, obviously you get syntax highlighting, so which you might not get if you're reading in a book. You get inlay hints and things like that. We can also structure and restructure the code. So first of all, if you're typing in the IDE, it will reformat for you. So the IDE will format your code for you, but if you find code that isn't properly formatted, we can reformat that, which makes it easier to read. We can restructure the code if we want to, for example, put the private methods below the public methods, just to help us understand the code a little bit better. I know we're reading the code to understand it. We're not necessarily there to improve it or make changes, but sometimes playing with the code a little bit while you're trying to understand it can help. We can collapse the code if the code is very long and confusing and we want to get a quick overview of what a class does. There are several ways that we can do that. We can, for example, collapse the code so that we see only the methods, and then we can expand a specific method as needed. There are other ways to get an overview as well. We can use the file structure, which again we can also use for navigation, or we can look at the structure tab if you prefer to have it off to the side. We have a physical structure tab, which looks like the file structure menu I just showed you. And for Spring projects, we also have a logical structure tab, which looks at the code more in terms of Spring concepts. And we are continuously working on helping to improve also how to understand Spring projects. So if anyone's going to Spring I/O next week, I'd recommend checking out the talks by my colleagues Anton Archipov and Marco Behler, who will be talking about Spring support in IntelliJ IDEA. So looking at the structure can be helpful. And even if our code is collapsed and we are searching for something, for example, let's look for payment. We see that where payment is mentioned in the code is highlighted, and specific code might even expand. And if we look for something else like payment info, then a different section of the code will expand. So we can still search the code even though it's collapsed and look for the stuff that we need. Or vice versa, we can also search from here. If we highlight something, then that will search through the code. Let me see, there are also different ways that we can pull up information about the code. So for example, one of the reasons that code might be confusing is a lack of information. So let's say we don't know exactly what a customer order is. We could pull up the documentation. I see that this one doesn't actually have documentation, so let's fix that. We can quickly write some documentation using AI Assistant. So that will generate some documentation, which is actually also a good way to get a quick overview of what something is or what something does. Often less verbose than using explain code and getting the explanation in the chat, although this is quite verbose for some Javadoc. If you prefer to have it in Markdown, we can do that too. So let's go back. So now when we pull up the documentation, we see the Javadoc as well. So that's one way to pull up information without having to navigate your code base and potentially getting lost. Another thing that we can do is we can do quick definition, so we can actually pull up the definition of the code, again, without having to navigate there. And also we might, let me find one. In this case, we have the inlay hints that already give us the type, but otherwise we can also pull up the type of a certain expression. So lots of ways that we can pull up additional information for the code that we're looking at. Another way that we might want to look at the code to help us understand the code is by going to the tests to see the behavior for the code. Hopefully the tests or the names of the tests express the intended behavior of your code. So that when the test fails, you will know what it was supposed to do, but also they can help as sort of living documentation. If all of the tests pass and the names are good, then they tell you what the code should do. This kind of goes without saying, but I have seen code bases where the test methods were literally called test scenario 1, test scenario 2, which is super helpful. I tweeted about it at the time, and 2 friends independently replied with, "But are you sad 1? Or sad too?" And I'm like, yes, I am. So, please give them meaningful names. It will help you in the future. Actually, it will help you now, because in order to give it proper names, you'll be thinking about what the code should actually do. Obviously, we can run our code through the debugger. Was anyone in Anton's talk earlier today on debugging with IntelliJ IDEA? Okay, for the rest of you, go watch that. For the ones who were there, sorry, I'm quickly going to do like the most basic debugging. But I want to show you just one of my favorite debugging features, and I don't know whether Anton already showed you that. So, if you run the code through the debugger, then you can observe the state of your code either inline or in the debug tool window. We can step over the code to go to the next line, or step into the code to go to a method that is called on that line. And then my favorite feature, or one of my favorite features, is evaluate expression. So you can actually evaluate expressions like so, and you can edit the code there. But you can also evaluate expressions that aren't currently part of your code. So for example, to see whether this matches 1, 2, 3, which it won't. So sometimes this is useful if you're trying to fix a bug and you have an idea of what it might be. You can actually evaluate that here to find out whether that's the fix that you want, and then go and apply that. So that's the one thing I wanted to show you for the debugger. There's way more possible with the debugger, as Anton has showed you. So definitely, I highly recommend you learn how to work with the debugger before you actually have an urgent production incident when you need to fix stuff, which I don't know about you, but I don't learn well under stress. So that is not the best time to learn how to use the debugger. Finally, we can also refactor the code as we're working with it. Let me find the right method. So if we're working with the code, then as our understanding of the code grows, we might also want to maybe change some of the names just, to help our thought process. So for example, we might have figured out that this item here is actually an order item. Thank you, IntelliJ. If we wait a little bit, AI Assistant will also suggest some alternative naming, which sometimes actually is better than the naming that IntelliJ IDEA suggests. So we can use refactor rename to rename stuff. We can also, if we're trying to make sense of some code and it's very long, we can extract methods. So for example, extract here what we're doing here is we're actually canceling the order item. So if you have a very long method, you can extract methods from that and give them meaningful names to you to understand what is going on. So in this case, cancel order item. In that case, you might no longer need this variable, so you might want to inline that. But alternatively, you might also want to extract variables and give them a meaningful name if you're trying to make sense of the code. So lots of refactorings that you can do. You can pull up a menu to refactor this, which will show you the most common refactorings if you want to see what kind of refactorings are available. Also, Emily Bage, who is a technical coach, does great refactoring videos that you can find online, and she uses our IDEs as well. So if you're interested in refactoring, I'd recommend doing those or looking at those. Obviously, since we're refactoring just to play with the code to help us while we're trying to understand the code, we roll back all of our changes because we were only playing with it. Finally, I also like to do a little bit of Git archaeology. Sometimes I want to figure out, hey, when was this code last changed? This isn't how I remember it, or what might be the reason that it's like this? So we can, let's expand everything first. Annotate with git blame. This is my stupid demo project that is half-baked, so it was written by me, myself, and I. But we could click on some of the commits to go to that commit in the Git history. Let's look at something a little bit more interesting. So we can look in the commit history to see what was changed. Obviously, we can look at the diffs for the code to see what exactly was changed in the code. But if there are a lot of diffs or a lot of files that were changed, we might also want to get a summary of what happened in a particular commit. So we can use AI Assistant to generate a summary of what happened in the commit. This can also be useful if, for example, you've been on vacation and you want to figure out what your teammates have been up to, get a summary of what they've done. You can select multiple commits as well. Obviously, don't select all of them. In that case, you can go in the chat and just ask AI Assistant to explain the project to you. And then if you want to, you can still look at the diffs for those files to see what actually happened. But again, I said I'm more of a top-down kind of person, so I like to have an overview first and then look at the details. So in that case, this might be helpful. So I showed you also explain commit. There are other AI actions that might also be useful. I like explain code, as I've mentioned. There are also explain regex and explain cron job or explain SQL if the code that you're looking at is any one of those. And sometimes ask it to write documentation for a class or a method can be useful to get a more concise explanation of that section of the code. So those are actually my favorite AI Assistant features over having it write the code for me, because that's the part that I actually like doing. It's the figuring out what the existing code does that is often frustrating. So lots of ways that your IDE can help you when you're trying to understand code, from the structure, looking at tests, looking at debugging, refactoring for understanding, and some AI Assistant features. My friend would like you to remind you that the plural of regex is regrets. I can't English today, sorry. Too many languages. And this is where I like to ask, who likes to write regex? See, there are always some of you. So for the rest of you, you can use this feature to explain those regex to you. He would like to also say that he got it from his manager, and also if you like these types of silly jokes, we also do a talk together that we will do at a conference here in Krakow in several weeks. So come see us there. Thanks. So outside of the IDE, you can look at structured exercises that I've mentioned, use memory aids like dependency graphs, state tables, diagrams, etc. Get more context for that code. A piece of code is part of a larger code base. Pull up that information if you need. Look at, hopefully there's documentation for the stuff that you're looking at. So what might be next for you is, if you are interested in any of the things that I talked about, like especially structured exercises and code reading club, you can go to their website. They used to organize online events where you could join one of their code reading clubs. I haven't checked to see if they have any events planned, but do check that out. If you're interested in starting your own club, you can do so as well. They have resources on GitHub with enough information for at least 3 sessions with a sample of code, exercises that you can apply to that, and notes for a facilitator. So, get your team or colleagues or developer friends together and organize your own code reading club. Or if you can't find other people to do that with and you want to do it by yourself, you can read The Programmer's Brain. It has lots of exercises that you can apply to your own code bases, and I highly recommend that book again. Obviously, let your tools help you, and don't forget to use your brain to apply all of your knowledge. Thank you. So you can find, as promised, the slides and everything here on my website if you want to scan the QR code or go to the link. And then let's see if there are any Slido questions, or feel free to ask me. I'll be around today, possibly tomorrow, if you want to talk about something. Let's see. In the age of LLMs, how important is this? Thank you. There's always someone. Skill of reading code. Can't we just prompt the model to explain the code to us? Yes, we can prompt the model to explain the code to us, and I find that very helpful, but you still kind of need to understand the code a little bit yourself. LLMs do unfortunately hallucinate, so what it's telling you might not be exactly true. So, use that and your own knowledge and evaluate accordingly. And I do still think that being able to read code is important, because especially if you're having Gen AI write the code for you, once you commit that code, you own that. So you better make sure that you understand what it does. Same as if you copy paste it from some tutorial, Stack Overflow, wherever. How did the IntelliJ as a game presentation make me feel? Is it hard to read? I love Alex. I love that talk. I've seen it 3 times now. 10 out of 10 would see again. When he explodes the code, it's definitely harder to read, but I just love how his mind works and how creative he is. So yeah, if you haven't seen that talk, you should definitely check it out. It's one of my favorites. Is vibe coding myth or reality? Certainly. I don't know. I can't do it. I'm really, really bad at vibe coding like an entire application. I'll ask, so we have a new coding agent called Junie, which I have here as well. So you can ask Junie, you can delegate tasks to Junie to have it write code for you, and it will create files, make changes in different files, run tests for you. You can tell it to make sure that your project builds and all of the tests pass. If some of the tests don't pass, it will go make changes to make sure that the tests pass. If you're interested in knowing more about Junie, definitely hit up Anton. And also he's done several live streams where he's building applications with Junie. But in terms of vibe coding, yes, there are definitely people who are vibe coding applications without caring about the quality of the code. I am not one of those people. I care about the quality of the code. Is performing code review for pull request opened in other repositories we don't necessarily beneficial in comparison with? Sorry, I'm parsing the question. Is doing a code review for pull requests, so summarizing my understanding of this question, is it helpful to do pull requests for code bases that you don't know very well, compared with reading the code? So depending on what tools you use, if you're using GitHub or GitLab, you can actually do those code reviews inside IntelliJ IDEA, which means that you can then also run the code, so that might make doing those code reviews easier. To do the code review properly, you'd have to understand the code base at least a little bit, in my opinion. But basically, it also depends on why you're doing those pull requests. and why you're doing the code review in the first place. Are you doing the code review to make sure that nothing is broken? Are you doing the code review because you will be responsible for maintaining that code, and therefore you need to understand that code if anything breaks in that code while the rest of the team is on vacation? So I would think about why you're actually doing the code reviews and act accordingly. I think we're running out of time. Why is IntelliJ taking so much of memory? Because it's a freaking powerful application. We're working on improving that though. So yeah, is there a feature of IntelliJ for adding notes to code that will not be committed? Well, so I like to use Scratch files. So here in the bottom you can create new files. Can be any type of file. So I probably have a notes.txt already. No, wait, I need to first say that I want a text file, a plain text file. So you can take notes and those won't be committed. Studies of better practice reading code in your working language or a novel one. So in our code reading club, we used different languages, and I found that I can actually, if I get over my initial, oh my God, I hate JavaScript, read JavaScript, and actually doing the structured exercises helps. And I actually like generalizing the knowledge of how to read code across languages. So I don't know if there are studies on what's better, but I found it helpful to apply it to different languages. How you have generated the Java diagram. So from the tool window, when you're on Java, there is a shortcut to draw the diagram. The shortcuts are shown in the bottom here, and then Java classes. Alternatively, Shift can bring up search everywhere, and then look for diagram, which helpfully gives you a bunch of diagrams, so also gives you show diagram. So if you are looking for particular functionality, Shift will help. Do you think var worsen the readability? So you have inlay hints. So even if you're using var, then you can still see the type with the inlay hints, or otherwise you can pull up type information. Sharing with AI assistants is a security or compliance risk. So you will, if you're using AI Assistant or Juni, we use cloud models, so your code will be sent to the cloud. If that is not allowed where you work, don't do that. We also have AI Enterprise, so if you need the stuff to stay on premises, look into AI Enterprise. So you can run your local model or you can run it on premises. Do code reading clubs work better in person, giving the printed out of the code? So we have an online code reading club because we have people in different countries, and we would each at home print our code, or there's also an online tool that you can use. You can find that on the Code Reading Club website. I've done them both in person and online. If you're good at collaborating online, which hopefully over the past few years we all have been, I don't really see a difference, but whatever your personal preference. With slightly over time, I managed to answer all the questions. If you have anything more, find me. I'm always happy to talk. Thank you.